Right, thank you everyone. My name is El-Haj-Mahmoud. I work at ARM, and my colleague.
Peter Pouliot from Ampere Computing.
And today we are going to go over the ARM server hardware management. So ARM servers, hardware management, that means we need standards. As you know, in the ARM ecosystem, we have multiple players, companies that build their own silicon based on the ARM architecture, and then they build their platform around that silicon. We have Ampere, for example, with the servers that you see here at the OCP that Peter is going to talk about. So in order to avoid fragmentation within the ecosystem and enable some common expectations for the end users of how the servers are managed in the case of hardware management, ARM leads a set of standards for server design. Specifically for this session, the server-based manageability requirements is a standard for how to design ARM servers hardware management to meet those expectations of the ecosystem. It is not a way to remove the room for innovation and value add. That's all there, from the silicon to the platform to the firmware. So our partners can still do all the innovation that they want, but it's at least to have a base foundation that is common and allow for some level of interoperability between components, software stacks, and the expectations of the end user. The specification is built on industry standards heavily, so it leverages DMTF standards from Redfish and standards from the PMCI work group at DMTF, like MCTP and PLDM and SPDM. There is also alignment with OCP hardware management standards and some of the work that's being done in the sub-teams, as well as support for legacy interfaces like IPMI. I'm not going to talk about why we are doing hardware management and why it's important. I think this is, everyone here understands that for the same reason that servers in data center, edge, off-prem, or in the cloud, the same scenarios, the same use cases apply to the ARM servers. So at a high level, the ARM server specification focuses on your standard interfaces that you see in pretty much any server with like I said, with common expectations of how to manage them in band, out of band, based on a manager like the BMC, as well as the ability to connect to peripheral devices, I/O devices, and platform components that are managed through the BMC. Redfish and IPMI are the key technologies for the in-band and out-of-band user-facing interfaces. This is just a snapshot so you can see the level of details and requirements that we have in the specifications. We're not going to go over all the wires and all the interfaces and what's optional, what's recommended, and what's the definition and use cases for each one. That's for you to read the specification and get in details definitions. But just to highlight a few examples of the interfaces we specify, we talk about connections between the server SoC, which is the CPU SoC, the whole system on chip, and the BMC. So examples like Jade connection for remote and at-scale debug, UART console and debug redirection through the BMC, USB connections for multiple devices for KVM or for Redfish host interface over a USB NIC, for example, PCIe connection to allow things like remote video through KVM or a mailbox interface over PCIe, I2C for IPMI. ARM servers do not have, for example, KCS, so instead we have the IPMI SSIF interface for over I2C. And then out-of-band network interfaces. We also have a class of interfaces that we call sideband interface. And this is important, and you will see it in the presentation here, mentioned a few times. Sideband interface is a connection between a satellite management controller, some kind of a microcontroller that's embedded in the SoC that's dedicated for offloading the management tasks and the management traffic between the server chip and the BMC. And that dedicated sideband interface, ARM specifies some requirements of how that traffic is handled, and allows for several use cases of sending management traffic to the BMC. There is a number of BMC I/O interfaces that we also cover that are very common with what's used in the industry, focusing on things like MCTP to the I/O devices over I2C or over PCIe VDM. So like I mentioned, there is good alignment between the SBMR, the ARM servers for hardware management, and the OCP driven initiatives around hardware management. For example, as a minimum Redfish implementation, for instance, the SBMR requires compliance to the OCP hardware management profiles. That's a starting point. In fact, we do have a statement there that's saying that we would like to raise the bar and define additional profiles or work with the industry on defining Redfish conformance profiles that meet the expectations of the end users for different use cases. We also have good alignment between the hardware management module and the ARM SBMR, specifically around the DCSCM interface, and we are part of the DCSCM initiative, and we have partners like Ampere who participated in the DCSCM and helped define the interfaces for the 2.0 specification. And finally, we have use cases that are also tracking with alignment to the work that's being done for RAS error management in the hardware fault management OCP subteam. OpenBMC is a go-to choice for a lot of the hardware management on ARM servers. ARM has been contributing some proof of concept implementations as well. As you recall, when I talked about SBMR, we said it's mostly aligned with what's in the industry, but we have some specific ARM definitions like the sideband interface. That's unique for ARM servers. So there is special development that needs to happen in OpenBMC to cover that specific interface. But then the use cases implementation are really generic. They things like logging the RAS errors or sending sensor data over MCTP are part of the contributions that either ARM or our partners work on pushing upstream to OpenBMC project. Now, we do not require OpenBMC on ARM servers. You can satisfy the requirements of the ARM specification using either an open source firmware stack like OpenBMC or a commercial firmware solution, for example, from independent firmware vendors. I'll cover a couple of use cases and then hand it over to Peter to talk about some of the Ampere work in this area. One of the use cases we have is the logging of sensor and event data coming out of the SoC to the BMC. Now remember, the SoC is a system on chip, right? So it has its own, it's not just a CPU, right? There are CPU cores, there's integrated potentially endpoints or accelerators or other devices. There are sensors for temperature, for voltage, for power utilization inside the chip, inside the SoC. And we want that data to be available for the management subsystem for the end user. And that's the role of that satellite management controller, that microcontroller that's embedded in the SoC that is implementation defined. So partners that build silicon like Ampere will then innovate and figure out how to build that microcontroller and how to connect it to all the subsystems inside their chip. But at the end of the day, the data coming out of that microcontroller going to the BMC are standard format using the DMTF MCTP traffic with PLDM type events. So we can then have generic code on the OpenBMC side. Regardless of the silicon implementation or platform implementation, it is going to see the same type of traffic coming from that microcontroller and then be able to handle that traffic and For example, show it on event logs on the web interface or make it available as part of the Redfish out-of-band data. The second use case I want to show here is the logging of hardware error management or RAS errors, like I mentioned earlier. I'm not going to go into the details of all the diagram, but at a high level, it's a very similar concept. You have errors happening inside the BMC, inside the CPU or memory controller or some other devices on the host. Instead of having runtime host firmware send those or log those errors to the BMC, like SMI, for example, we can offload the logging of those errors to the sideband management controller, to that satellite management controller and the sideband interface. And the format is also using industry standards. So the errors, ARM requires the errors to be packaged as CPER errors, the common platform error record that's defined in the UEFI specification. And that's also aligned with the recommendations of the OCP hardware fault management subteam. The CPER data is then packaged in PLDM, DMTF defined PLDM MCTP traffic that is logged to the BMC. And same, you can have generic OpenBMC code that shows those events in the log or make them available out of band through Redfish. On that specific use case, we worked with DMTF to enable a couple of pieces in the specs that were missing for this in order to enable this complete end-to-end story of logging the RAS errors through Redfish. So the first one was some enhancements that were done by DMTF to the Redfish, making the CPER data available out of Redfish. There is already a Redfish schema to make diagnostic data available out of Redfish, which is the diagnostic data can be of different types, CPER being one of those types. The new improvement that came from DMTF very recently, and thanks to DMTF for being able to get that work in progress draft published on the DMTF website, adds a human readable error message. So you can have something that the end user can see in the log, for example, or the user interface that correlates to that CPER error, as well as the ability, if the CPER data is of small size, the ability to embed that CPER data in the message itself in the Redfish event, so it can be transferred with one payload rather than getting the Redfish event and then downloading the diagnostic data separately. The second improvement that is still also work in progress in DMTF is the definition of the CPER PLDM data type as an event. That is currently not defined in the DMTF specifications. There's a proposal, a work in progress proposal that is shown on the website as well, and you can go and review those proposals. And work is being done with DMTF to move that forward. Feedback to both of these proposals, Redfish and the MCTP, the PLDM definition of CPER is welcome. So if you have any feedback, please submit it to through the DMTF portal. And finally, as part of this effort, ARM is contributing a library to parse CPER error records and be able to generate CPER error records as well. So it does JSON and CPER binary conversion both ways. The library is written in portable C code. It's available right now on ARM open source code repositories. It's an Apache license, free for all. The idea is to find, there are use cases for this library. For example, inside OpenBMC itself, if OpenBMC needs to parse the CPER record and make it available as an event, decode the data, for example, and show it to the user. Or it can be a standalone tool that is used by remote administrators when they are analyzing the faults. And I'll hand over to Peter.
Thank you, Samir. So one thing that Ampere has always been committed to through the process of evolving our platforms is, trying to help advance and, adhere to the standards, because we know that changing architectures can be sometimes philosophically challenging in terms of, the leap of faith. So being able to deliver platforms that adhere to specific standards for data center operators to know that they can take our platforms, put them into their infrastructure, and essentially have the same user experience that you would, or in some cases a better user experience, from a systems management perspective. We don't want to necessarily come out of left field and have a completely different user experience and change the way you think about operating your data center. So as such, early on we've decided to actively participate in OCP. And last year we basically got our first OCP certified platform, the Mount Jade. And as you can see here, the Mount Jade essentially is the first and only ARM64 system-ready certified and OCP accepted platform. The specification and design files were released, as I mentioned, to OCP last year. If you heard our recent keynote at the beginning of the week, we're committed to releasing our next platform also to OCP. The Ampere Mount Jade is available on the OCP marketplace and is also, as Samir said, it's system-ready, SR and LS certified. So Ampere has also early on committed to maintaining and constantly contributing to OpenBMC. We believe that having a choice of firmware for our platforms is a great opportunity for us to not only advance the momentum of open source systems management, but also gives choice to our customers and people wanting to use our platforms in their data center infrastructure. On this slide, you see we have the links to our OpenBMC repository, as well as some other links to projects. We have committed to, as I mentioned, a monthly release cadence of ongoing contribution into the space. And we also rebase that code base on a regular basis with upstream OpenBMC. Now, for the Mount Jade specifically with Ultra and Ultra Max, we maintain and continue to fix bugs. We have a base meta Ampere SSFIB bridge upstreamed, and additional codes and patches under meta Ampere continue to be upstreamed over time. And as we mentioned at the beginning of the week, the Mount Mitchell platform, which is our next OCP platform, which will have the Ampere 1 processor in it. Initial support for OpenBMC will be found in the Ampere OpenBMC GitHub repo. And it'll include Ampere 1 telemetry support via MCTP and PLDM. So this is a snapshot of our upcoming roadmap that we're looking to contribute back in the this year and through the end of the year. And I'll let you guys dig deeper into that if you'd like later. So, and actually, if you come to the Experience Center this week, you'll find our Mount Jade platform with OpenBMC. We also have another platform that ARM was gracious enough to have built in a desktop form factor, the 80Link platform, which also has OpenBMC as system management. And that also supports Tiano Core DK2 and Linux boot as well for the Mount Jade. So as I said, one of the other great things that have happened this week that some of you may noticed is HP is now shipping the RL300, which is what I believe is the first enterprise server to ship with OpenBMC as an option directly at the time at which you purchase. More information of that can be found here on this URL. And you can actually come and see a demo of it with a full life cycle of the provisioning of the OpenBMC firmware in the Experience Center, located right alongside the Ampere station. This demo is a little different because it changed over the course of the slide deck. But as I mentioned, they have a full PXE-based provisioning infrastructure delivering the OpenBMC firmware in the Experience Center, and you can come and actually see it happen in a full life cycle at that time. So let's continue. So essentially, the call to action here is feel free to, as I said, come to the Experience Center. There were some previous, I think they're actually over now, previous talks that were given by Ampere folks. And we actually have another talk coming up a little bit later on hardware management, I believe. Or, yeah. Anyway, thank you very much. Appreciate your time, and we'll take questions for anybody who'd like to ask them.
I think we have time for one question.
Do you make your OpenBMC builds for Mount Jade? Do you publish them on Ampere Connect?
So we provide the reference implementation, and all that is currently on actually on GitHub. We do not actually release the binaries. That's up to the ODM, ODX that would provide the actual hardware platform that you would be consuming for that. No, we don't. We provided the reference platform. We provided the architecture to OCP. We don't actually produce or manufacture that. So if you went through the reseller, you would have to work with them to actually get the physical binary. Or we could actually, if you go to the GitHub repo, there's instructions on how that we provide in the information in the repo for how to build it yourself and create the binary artifact. Well, because we work with ODMs and ODXs directly, right? We're not necessarily, I guess, built for releasing those binaries ourselves. So, yeah, and specifically, you would have to work with them. But as I mentioned, we'd be more than happy to assist you through the process of being able to generate those things in-house, through, our documentation and other stuff. We try to make it easy, but because we're not that, we basically work more on the IP side of that. And as I mentioned, like to deliver the reference implementations for our platforms that, we use to essentially, prove out the concepts of our chip and stuff. You have to, everyone is different, and not all of the ODMs or ODXs may necessarily implement OpenBMC on the platforms that they ship. So yeah, it depends on the platform and who actually manufactured it.
Okay, I think, thanks. Let's thank our speaker, Peter and Samer. Thanks for the presentation.